I'm going to talk about a project I've been working on for some years now. 3D printed arm, as you can see, and hands. An IOT board inside, and some Xamarin work as well for the mobile app. And the process that I've gone through is not a complete project. This is still a work in progress. So there are bits in the code that are not quite right and not best practice, that sort of thing. It's getting there. It's an iterative process. Bit about me though. Those who don't know me, my day job is that of an airline pilot. I reference it just because I'll come back later and say one of the reasons about this project as well. It's not just me saying I'm an airline pilot, look at me, honest. But when I'm not flying planes, or sometimes when I'm flying planes, I do development work, freelance .NET, Xamarin developer, quite a lot in the IoT and Xamarin space at the moment. Got a family, wife, 3 boys, a couple of dogs, and I enjoy cycling. So that's me. But we're here to talk about Kayden. And this is Kayden, now 15 years old. As you can see, he's a happy-go-lucky child. They do exist, happy teenagers apparently. He's one. As you can see, if you look at the picture here, he's quite big into the scouts. And he goes on all the scout camps, jamborees and that sort of thing. You can see Kayden is missing his left forearm. So from his left kind of forearm onwards in his hand. And if you look at his other hands, he's got a thumb and a pinky. He's got nothing in the middle. He's got like a stub. And you know, there's been all sorts of talk about, you know, claw grip and stuff like that. But so he hasn't got much dexterity in that hand because he can't really pick stuff up because he's got the lump of the fingers in the middle, the proximals, and he's got nothing this side. So it's been a bit of a challenge. So go to the NHS as you do, and wonderful NHS, fantastic service. But they give you, wherever it is, the arm that is being passed around. That bit, yep, if you hold it up for me, there you go. Yay. There's audience participation in this talk, I'm just telling you now, lots of it. You can see he got given a, this was 2012 Olympics, getting the train up to the Paralympic Games, which he was invited to. That's the arm he had at the time. It's moulded out of plastic, and you can see the claw grip on the end. And it's closed with elastic bands, so they're best friends of the postman because he leaves them lots of elastic bands to fill it in. You can see the wire here goes up across his shoulder blades to a pad on the other shoulder. And it opens and closes the grip like this. Yeah? So that's how it actuates the claw. He's been using this for many years, so he's used to it. He's been using it since 5 or 6 years old, iterations of this arm. So he's very, very dexterous with it. But every kind of year-ish, he outgrows it. Kids tend to grow, you know, wish they'd stop. So you can see he's got, you know, he went from that arm, the red one, to the green one. I think the green one's here. He's now got a black one, which is the NHS. But every time he goes along, he just picks another colour off the chart and they make it out that colour for him. But it's always the same claw on the end. It unplugs it, plugs a new one in. The little green hand that was going around has got the little adapter on. Now, yep, there you go. Oh, you've got Wait, I thought you was doing this, yeah? You can hold the little, I'm only messing, Layla, okay. But the little clip on the end is that bit there, plugs into the end of the arm, and that's how he connects the claw, and then the wire he wires it through. So, about December-ish in 2016, so 3-ish years ago, 4 years ago even, no, 3 years ago, isn't it? Sharon, Kayden's mum, come to school and was waiting for school pick-up. Our kids go to the same school. And she said, have you seen on the news about the dad that printed a 3D printed arm for his daughter? I went, yeah, I did, Sharon. I see it when I was on my practice. You've got a 3D printer, haven't you, Cliff? Yes, Sharon, I have. So that was where it started. She said, any chance you can have a look? You know, because Kayden's got this NHS arm. It's not very good. Can you have a look? I was like, yeah, okay, I'll have a look. I went home, as you do. So, well, let's see what Kayden can do at the moment. Yeah. So, hold my beer, watch this, and hopefully this should play. Excellent. So, this is Kayden using his arm with his claw, making his dad a cup of tea. So you can see in a moment you'll see in his right shoulder you'll see the pad as he turns. You can see the elastic strap across his back. So that's effectively how he's actuating that claw. You can see he's making a cup of tea. He's picking up tea bags out of a pot. So he's quite dexterous. Yeah, he's been using this for years. Human body is amazing. The brain, the way we can learn. If you take a body skill away, the body adapts and learns. Absolutely amazing the fact that he's managed to do this. And he goes on and makes a cup of tea. So I thought to myself, right, well, I know what he can do, because I've seen him do this. I've been to his house, that sort of thing. I'm hoping this works. Oh, yes! Using the different, what are they called? Desktops, that's it. So, bit of Googling. As you do, you think to yourself, well, the NHS make these arms. Let's start there. So I went to the NHS website, which linked through to Limbless Association. This here is live in my browser now. This page is exactly the same. I started this in 2016. They're still developing this page. I mean, at some point it's going to be finished. At some point the developer will be allowed to go and do another job, maybe allowed to go home, but they're still developing this page. It's going to be amazing, I'm sure. Or someone's just completely forgotten it. Yeah, it's not even secure either. So yeah, I mean, someone will get around to sorting this out for the NHS at some point. I mean, it's a charity. I might actually just go and chat to them and say, you know what, do you want me to fix this for you? Because it's getting embarrassing now. So, there's my pointer. So I found the story about the dad, and I come across a website, Team Unlimited, and their arm. This has obviously moved on, because this is live on the web now. But their design at the moment was the hand. You can see it has these pulleys here, and it works the same system with the pads, and the hand opens and closes. So we started off with their early version, which is similar to this, and built it, 3D printed it, gave it to Kayden. He put it on his arm, tried it for about 30 seconds, says, I hate it. And the reason being, and I wanted him to be honest, yeah, I like feedback where it's honest, was because he can't grip stuff, yeah? So with his claw, because he's so dexterous and he can do stuff, but with this he couldn't grip stuff. He could hold stuff, but he couldn't pick stuff up. He couldn't get the tea bag out of the pot. So he's like, don't like it, it's horrible, I'm not wearing that, and it went off in a teenager strop. It's fine, okay. Yeah, his mum was all nervous about the fact how I'd feel about that. It's like, no, it's fine, as a pilot, we're used to getting feedback, sometimes negative, sometimes positive, when we're going to the sims and stuff like that. It's like, no, I'm happy with that. At least I know. If you hadn't have told me, I would have been, right, job done, off I go. What's next? But we moved on. So a bit more Googling and bingling and searching, and we come across the Open Hand projects. These are a bit more kind of technical. They've got some motors in, a move, electromechanical ones. I was like, actually, you know what? That's quite handy. I like that. That's quite good. Let's do something with that. So you can see the thumbs up there from the dexterous. So I printed a version of that and started working on that. And it was like, well, it's not quite there. It's open source, but it's not really there. So then I come across OpenBionics. Now this is their website has changed drastically over the last year. They were open source. They did have a GitHub for the software. Everything was open source, the designs, the lot. And about 2 years ago, early 2018, they stopped iterating the open source, started a business, and started selling their hero arm, which is a fantastic bit of kit. And as you can see there, what they've managed to do with it. But it's no longer open source, so they've kind of gone closed source and iterated design. So I took the ideas in the open source community, myself being one, all the PRs and things like this, and then decided actually we're going to make a business. Good luck to them. They're doing an amazing job. They're not cheap arms. I've spoken to some people who got them that have kickstarted their own arms, and they're upwards of like 10 to 15,000, if not more, depending on what you need done and the amount of effort that's needed to be put into it from the prosthetics surgeons and things like this. So that's there. So I went from that, took the open source design, forked it, and started iterating myself. Oh, wrong one. So, as I say, I fired up the printer. I'd done a first print of my old Mendel printer, and this is what I got out. As you can see, it's not very good. It wasn't good at all. So what do? You obviously buy a new one. So I bought a Prusa Mark III or i3 printer, which is a build-it-yourself kit at the time. It cost £800, so it wasn't a cheap printer. But I needed it for other projects. I do a lot of IoT work, so building little bespoke boxes and stuff for my IoT projects as needed. You can see I've circled the little blue bit at the top. When I was building it, I broke that part. And the good thing is that a lot of the components on there are all 3D printed. So I fired up the old 3D printer, and about 20 attempts later, got the little blue bit that I needed to fix the new 3D printer that I just got out of the box. So, but that's a good thing, 3D printer. If it doesn't work, if you break something, you just go and print a new one. There's a knob on my cooker at home, which is 3D printed. You know, my kids have printed their homework. You know, they've done designs in Minecraft and printed it out to take to school as an extra, you know, A-star kind of thing. So there you go. So eventually managed to print all the parts from the Brunel hand, which is what this is, and all the parts, all the screws, nuts, bolts, springs, and the little brass inserts which you put in with a soldering iron so you can screw screws in, so you're not screwing into plastic. Got the expensive parts of the project are these 4 motors, which are the Actronics linear actuators. So I've got all the parts now, it's excellent, we've got the parts. Right, so we can build a hand, so I built a hand, it works. Right, oh, brilliant, excellent. Right, well, now how do we attach this to Kayden? So, we took his model from Roehampton Hospital. This is the model they used to make the green arm. We took that. My oldest son, Macaulay, is a dab hand at doing 3D design, and he took that and hand drew in Blender this. I don't know how he did it, it's magic. And we ended up with this socket here. As you can see, if you watch there, it was printing away. The problem was that it was printing away, and I was like, excellent, it's printing, I'll go to bed. So off I went to bed and come down in the morning to a mess. When you 3D print things, sometimes they don't stick to the build bed, and they pop off, and the printer knocked it off to the back and then carried on printing into thin air. We ended up with a spider's web of mess. Thankfully, it printed enough that I could clean up with a scalpel blade, and took it to Kayden that evening and said, here, Kayden, try that on. That one was too small. Okay, fine, it's 3D printing. It cost about 80 pence to make one of these. So we just grabbed the slicing tool, just grabbed the object and made it 5% bigger. No, 10% bigger, I think it was. Printed that one, which was too big. So we got too small, too big, so I went 5%, printed the third one, and thankfully, it fitted perfect. So version 3, fitted like a glove, and Kayden even thought that it fitted better than the one he'd been made at Roehampton Hospital. So for 80 pence worth of plastic. So that was awesome. That was the first win. So now we've got something where we can get Kayden. We haven't got the bit in the middle, but that'll come later because you know that's just the arm. That's fairly simple design. So all the 3D printed parts, the hand parts are these bits in the middle. All the different materials, so we've got PLA, which is that, polylactic acid, we've got PETG, which is polyethylene glycol, something or other. You know, it's a bit flexible, basically. And then you've got the bits in the middle, these red bits, or on Kayden's arm, the green bits in the middle, which are the ligaments, are printed in a flexible material. So you can see here, the moulds we'll come back to later, but the actual costs, £4.93 and 20 pence for ligaments. So we're talking £5.13 to print that. It's not a lot of money, is it? Compared to the many thousands that the NHS spends to get a special person to make one of these. I mean, skill and everything else in there, it's amazing, but you're talking £5 for one of these. If he breaks it, we'll just print another one. Not much. You know, he's broken a couple of fingers, but the finger parts are £1 each. It's fine. Here you go, Kayden, it's a spare. So, we've now got our hands. We've got our dumb hands with nothing in it, no electronics, anything else. We've got a socket, so we can connect it to Kayden. Now we need some control. So OpenBionics, as part of their Brunel hand, sold this board, the Chestnut board. They open sourced the electronic design. They open sourced all the software that was on it. But the problem was that you had to buy the board from them or go and have one made yourself. Their store never had them in stock. You know, for many, many months, 3 or 4 months, I tried to get one. I kept speaking to them every week, can I get one, can I get one, can I get one? And basically what they were doing was waiting until they got enough orders or enough potential interest that they'd do a batch build, get them in and sell them out. That's not ideal, is it? Because if Kayden drops it in the water, because he goes, you know, and does things with the scouts, drops it in a puddle and it fries the board, he's got to wait many months to get a new one to get his hand back working. Obviously, they're going to keep them for their own customers and clients, but they're not going to sell them to third parties like myself or Kayden. So I was like, well, I don't like this. This is not, you know, I looked at getting them built elsewhere, but it's going to be mega, mega expensive. We're talking in the thousands to get a bespoke one-off build run done. So I was like, right, I'll come back to that later. How do OpenBionics control? At the time, they used these MyAware sensors, which I think got passed around, so a few of you played with these here. And they read the muscle sensors, and they've got little sticky pads, just like you have when you have an ECG, a little sticky pad stuck on you, which are okay. A pack of 50 like this costs £5. So 50 pads, you have 2 sensors, so that's 6 pads per day, and you get 50 in a bag for a £5. So £5. It's going to be a bit, what, 8 days? 8 and a bit days worth? Yeah. And so every kind of week, they're going to spend £5. And it's like, yeah, I don't like that. That's expensive for me, because I want this to be as cheap and usable as possible. You know, remember, I fly around the world, so I want places around the world to be able to take this and not have this ongoing cost. So how do the sensors work? Let's look at how they work and see if we can iterate. So the MyAware sensor goes on the muscle. Yep, goes on the muscle and reads the muscle reading just like an ECG does. So it reads that, and you have this fly lead one which goes in the null zone. So it compares the readings from the 2 main ones on the board to the null zone, and then gives you a signal out. The idea is you put it on the center of the muscle mass, and it gives you the best reading. But if it moves off slightly, even slightly to the side of the muscle mass, you'll see the purple one, which is midline offset. There, the reading is pretty dull. So it's not going to give you very good readings. So it's like, it's okay, but it's not ideal. Bear in mind, Kayden's had no forearm, so his muscles are really underdeveloped. He's never used them. So when he starts, we've got to turn the gain levels right up, yeah, and it was really noisy, even when he wasn't using the muscles. So as he gets more use of tensing these muscles, then they will gain. The gain will be too much, so you've got to twist it down. So what OpenBionics and other teams do is you go back to the hospital, and the doctor looks at it and plugs in some sensors, and then they dial back the gain levels on the board. There's a little potentiometer in the corner. You dial it back a bit. Does that work? Yeah, that's okay. Right, off you go again. So every few weeks, they kind of look at this. It's like, oh, that's a lot of travel. So I don't like that either. It's not working for me. So as I say, it's not to scale. My muscles are nowhere near as big as that. But you can see how it works. So audience participation time. I said that we stick these sensors on, so you stick it around there. So if you could put your arm up like this and put your fingers either side, you need both hands, so don't spill the coffee. Yeah. If you are to move your hand back like this, that back muscle there tenses. Yeah. I'd love to know the medical term for these muscles, but I can't pronounce them. If you move your hand like this, that front muscle there tenses. Yeah. And if you keep your hand straight and grip, both tense. Yeah. So we've got 3 moments. I love the fact that the camera people are doing it as well. So we've got open, close, and the grip is to change. Yeah? So we can open the grip, close the grip, change the grip. So, brilliant, right, we can do that. OpenBionics have come up with these 5 grips that they think are the most useful in everyday life. So you got the fist grip, you got the palm grip, which is carrying the carrier bags. Kayden asked for that to be removed because he doesn't like helping with the shopping. Got tripod grip, which is for holding a pencil. Yeah, so that's quite handy because Kayden can't really hold a pencil with his other side. You got the OK grip or pinch grip, yeah, which is your OK grip, and then you got the point that's over there, mate. Yeah. Kayden asked this one to be replaced for a special one for his teacher, which is something to do with the middle finger. I don't know, but you know, there you go. But these grips, yeah, we're software engineers. We know what software looks like. That's how the grips are made up. And if I do it again, it should animate, I think. Yeah, there you go. Right, so this is how the grips are made up. So it's a 3D array, yeah? So when we look at the thumb grip here, it starts off with a counter that goes from 0 to 100. And there's an animation timer of how many steps that is. At the moment, it's set at about 2.4 seconds, because that seems to be about the right speed to make it work. So you start off at 0. Yeah, so F0 is the thumb, F1 is the index finger, F2 is your pinky, and then the pinky is back here. There's only 4 motors. There's only 4 motors. So you've got one for the thumb, one for your index, one for your middle finger, and these 2 move together because you never really do independent finger movements. You kind of always do them together. So you have open, and the index timer, the animation timer starts running from 0 to 100 over the given time, which is set in a value. And it looks at, well, if that says blank, I'll look at the next one up. So I'm still going to keep that finger fully closed. I'm still going to keep that fully closed and get there. I'm going to still keep that fully. So it moves to the position that is the one above. Yeah. And if it gets to one, where's one there? There you go. So fully open to 700, it starts between 0 and 10. It starts moving towards the 700 position. and then it gets there and it says, oh, that's still 700, so I'll still stop at 700. That's 750, so between 40 and 100, it will move that last bit, yeah? And as it animates, so you've got to be quite good at thinking about where you want the fingers to be moving to get a fist grip, so the thumb closes inside the fingers, that sort of thing. It's not easy, is it? It's a 3D array. Us as software engineers can look at that and think, so yeah, my brain can work that out, I can do that, yeah? You can't imagine a doctor in a hospital doing this. You can't imagine a child or a parent at home being able to cope with these. So I was like, well, it's okay, but we could do better. So, drawbacks so far, which we've talked about. The processor board, single source supplier, I can't get one. It's expensive, it's £250 plus VAT, so it wasn't cheap either. The malware sensor board is weak, it'll build. You don't really want to try playing with the sensor board, they've got to stick it on every morning. They're $35 each, £35 each. They're going to break it, aren't they? There's two of them, they've got to stick it on every morning. You know, my mum and dad are trying to make the packed lunch and get the school bag packed and get out the door before, 10 to 8, that sort of thing. It's going to break, and they're quite expensive to replace. So I was like, well, don't like that. And we talked about the sensor pads. Other thing is, that sequence, that grip sequence, is every time you change grip, you've got to go around. So if you miss the grip, you've got to go all the way around the grip cycle to get back to the one you want. Yeah, and it's not, you kind of miss it. It's like, oh, crap. And you kind of do it quicker, which means you miss it again, and you just get more and more frustrated. I was like, I don't like that. Let's see if we can change that. And you might want your own personal grip. Kayden's asked for one that he can control his Xbox with. I get that. I play games. So, yeah, okay, what can we do? What can we do to make that better? So, let's fix the processor. So, the Adafruit processor, Adafruit is a company in New York, and they make lots and lots of IoT boards. If you've never heard of them, go to the website. It's like a playground for IoT and tech and stuff like that. It's brilliant. They brought out this board called the Feather, and they call it a feather because it's as light as a feather. A big feather, apparently. But it's an Atmel ARM chip sitting on there, and this red section at the end is the Bluetooth enablement. So you can get ones where that prototyping area at the end has got Bluetooth, Wi-Fi, SD logging cards. There's 30 or 40 of them. It's, go and look at the website, they're awesome. These are £28. You can get them from Amazon, which is lucky, because last year I blew one up 2 days before conference talk, and I was like, crap. Quickly on Amazon, ordered it, postman delivered it the next morning, I managed to resolder the board in, and all was saved. So these are widely available, no matter where you are in the world, you can get one of these for not a lot of money. So brilliant, that's it, we'll go with that. There's some specs on it. It's, as I say, light as a feather. It's got an Atmel. It's 3.3 volt logic power. That was a bit of a pain. It's got no EEPROM, so you can't store stuff, but there's other ways of getting around that. That was a bit of a pain as well. But it's got enough analog inputs, PWM pins, and it's got its own LiPo charger as well, which means we can charge the battery using the USB port. We can charge the battery backwards. I was like, excellent. So we got a couple of those. We also got the motor controller board, which is the second one in here, which drives the motors. And so the main controller, rather than having to use all the PWMs and its processing power to talk to each motor individually, it just sends a signal via the I2C communication protocol across the motor board and says, move that motor to there. And then the processor on that board worries about getting the motor to where it needs to be and all the faults and etc. So got those. And you can see the end of the Actronics motor has got this flat ribbon cable. And it was like, well, how do I connect that? So through holes. Okay. So I managed to solve it in the end by getting some little connectors from RS Components and sitting there and soldering them on by hand. But they're surface mount connectors because they're that small. I was taught when I did an engineering career with Ford Motor Company on Curran Street how to do, I went on like a month-long soldering course, how to do all these sorts of techniques. So I could do it, but that's because I'd been trained to do it. I wanted to make this easier. So that was another tick on the drawbacks list I wanted to solve. You can see here, there's a little extra board that's floating off in mid-air on some cables. There goes a circle around it. That is taking the 5 volts from the battery and stepping it down to 3.3 volts. And that was because the board needed 3.3 volts. That was, I think, about £6. But it meant I got 5 volts of the battery down to 3.3 volts. And there's the FPC connectors. So back to the drawbacks. So actually we've got a board now. So we can cross that off the list. That's done. Right, the malware sensors, what we're going to do with this. I read this magazine. It's an awesome magazine. If you like IoT, you like tech, you like weird things, making kind of flashy lights work on your shirt or your dress or whatever. They've got all sorts of ideas in there. So I was reading that literally on a flight, flicking through it somewhere over Russia, and I come across this Arduino debugging. I thought, oh, okay, fair enough. Yeah, what's that about then? And he goes through about how to debug Arduino, instead of print line statements, flash LED that many times and that sort of thing. But I noticed this. I was like, what's that? And in the code, it's just a piezoelectric sensor. So we've all got our little piezoelectric buzzer in our laptop or our computer that buzzes, 4 times for the memory's broken or whatever it is, or GPU or whatever. That's basically what that is. You pass electricity through it and it'll buzz. But this one, you squash it and it will give you an electrical output. So, oh, that's cool. What's that? Couldn't wait to land to see how much they were and where I could get them from. Amazon, pack of 10, I think it's £1.80. So couldn't wait to get home to try it, integrate it, put it in, we stuck it in the arm, gave it a try, and it worked. I was like, brilliant. We've now got rid of these 2 £35 sensors, all these sticky pads, and I can get a pack of 10 for £1.80. This is awesome news. Took it around to Kayden, give it to Kayden. Kayden, look, we've got new sensors, try this. He was like, oh yeah, great. He tried it for a while. He's like, this is good. I can't stop in the middle now, though. I was like, what? Well, with the other ones, I could kind of start to close it and then stop. And it stopped in the middle. But now I can't. Now I can either open it and close it. And I was like, yeah, I kind of had to take that out and say, yeah, but I kind of want that. Okay, yeah, fine, got you. Right, okay. We'll try again. So again, we're wandering along, and I went to SparkFun. I was like, I'm going to fix this sensor thing. SparkFun, another thing like Adafruit, they do all these funky toys. Again, another American brand, company. And I found these sensors. They're £6 each. But as you can see, as he's pushing down the GIF, you can see the pressure readings going up and going down. And all it is a force-sensitive resistor. As you apply pressure, you get a resistor value out. More pressure you apply, the bigger the value out. You then put it with a couple of other resistors to balance the how quick it goes up and down, the pressure reading. So I was like, excellent, bought those, couldn't wait to fly home so I could put them into the circuit. And we ended up with, this is the circuit. Fritzing, if you're doing IoT, awesome tool, it's free download. So we ended up with the main Adafruit boards is there, that's the motor controller board, there's our 4 motors, there's our 2 force-sensitive resistors, and then we've got our voltage converter to take it to 3.3 volts from the battery. And we've also got this other board up here. The motors need 12 volts. Yeah. So I wanted the battery, instead of being what OpenBionics uses, which is a big RC battery out of a radio controlled car, which is 12 volts. I wanted to be able to not use this big heavy battery. It needed a special power supply, special charger, because again, I wanted this to work no matter where you was in the world. So I got one of these power bricks, Anchor power bricks, 10,000 milliamp hour. I had a couple of those sitting on my bench. I was like, well, that gives out 5 volts. If I step it up to 12 with a step-up transformer, then I can power my motors. And the 5 volts can also power via the other one, the 3.3 volts. They're not expensive. They're about £20 each. So I went onto SparkFun and Polyloo and found their step-up board. It's about £7. So awesome, we'll get one of those. So we got one of those, stuck it into the list of parts we need, and yeah, it worked. So now I can power the motors all from a 5-volt battery, which means that you don't need the Anchor one. You can use whichever power supply you've got, which could be, no matter where you are in the world, could be a different form factor, yeah? Which is why we've not done the ARM yet. Downside is, Kayden was using it, goes to school, and the teachers and everyone else is like, oh, Kayden, my battery's flat on my phone, can I charge my phone, please? So he'd often get home with his arm not working, stuck in the back of his backpack because his battery's gone flat because everyone's charged their mobiles. But hey-ho. So now we're back to our drawbacks list. So we fixed the sensor now. We've got these force-sensitive resistors, and they work perfectly. We demoed different sizes, so we demoed these slightly bigger ones, which seem to work for Kayden better than the small round ones. These were a little bit more expensive, they're about £8 each, but literally push them and it controls the hands. So we're back now to looking at the bits for the grip sequence and the likes. So like I said, I do a lot of Xamarin development, and I was like, well, all this setup and everything else can be done in the mobile app. We've got Bluetooth on the board. Let's see if we can link the Bluetooth on the board to our mobile app. So Bluetooth, it's confusing, isn't it? Has anyone worked with Bluetooth? It's not very nice. You got Bluetooth Classic, you got Bluetooth LE, you got Bluetooth 4, you got Bluetooth 5, you got Smart Ready, not Smart Ready, you got Smart. It's so many acronyms. But basically, you got Classic, which does streaming of stuff. Yeah, that's the old Bluetooth of the old. And you got the Smart LE, yada yada yada. All the other acronyms, depending on what company and brand name, etc., is the stuff that does things like heart rate monitors. It sends small little packets of data. And what it does, you have your central device, in our case, a mobile phone, and it connects to the peripherals. So it'll connect to your Garmin watch, for example, while it's also connected to your hands, while it's also connected to whatever other thing it is, like your headphones and stuff like that. And it sends small packets of data. So they agree a timing interval, a connection interval, and the master, the mobile phone, sends a request and says, give me this data, and the slave responds. And then at the connection interval, again, it sends a request and it sends a response. Yeah? So it's controlled from the master device. Inside each Bluetooth, so my Garmin watch, the Adafruit board that's there, you have a profile, that says that's a Garmin watch, that's an Adafruit board. Inside that, you have a service, different services. So we take my watch, for example, it'll have a service for the heart rate monitor, it'll have a service for the time, it'll have a service for how many steps I've done, it'll have a service for my sleep cycles. Inside that, you have a characteristic. So think of this as your class with your attributes inside your class. And that's pretty much what it is, but it's broken down that way. So in the Adafruit board, there's only one service, and the characteristic is TXRX, so transmit, receive data. So she's got two buffers. That's it. It's dead simple. So you couldn't really go wrong. So if I go across, which one's that? There you go, OpenBionics. So inside my Bluetooth setup, this is the OpenBionics setup. They're beetroot boards, which I've downloaded and forked, and then I've heavily changed. I've added lots of Adafruit parts in, stepper motors, a bit of flash storage because I didn't have the EEPROM. So I'm storing it in flash, which is okay, but you only get about 10,000 bytes before that flash bit decides it doesn't want to work anymore. So you just have to be a bit careful with what you're doing there. What have I done now? There we go. So, in the Bluetooth setup, Adafruit, for all their boards, release fantastic libraries, which is what we talked about up here, the Bluefruit NRF library. So basically, you do a Bluetooth, you create an instance of their class, and you say begin. That's it, and it will do the connection for you. It will set the Bluetooth up for you. You then do, you check that his factory reset is enabled, because on some boards it's not, so it's a requirement to do that, and we do a factory reset. The reason I do a reset every power on is just to make sure that the Bluetooth is going to set up how I want it to be set up. It's not got any crap laying around inside registers, and it kind of zeroes everything out. And then I send a check command and give it a name. So I'm sending it, are you okay? Are you connected? And I name it, and in this Bluetooth device name, at the moment I call it Handy. On Kayden's, I think it's Kayden's arm or something like that, something that we can change. We turn off the echo because we don't want it to respond with everything that we send to it. And that's it. That's pretty much the whole Bluetooth stack that's done. And then you can just send it. And what I've done in other parts of the code, where OpenBionics had it such that it did serial print for debugging to the serial port, which you can watch on PuTTY or on your serial monitor. I hacked into that and said every time you send something to the serial port, send it to the Bluetooth as well. So that meant that I could debug on my phone, which is awesome. So that's our Bluetooth. So now we've got Bluetooth, we can connect to a mobile phone. I said I'd do a lot of Xamarin work, so obviously I'm going to pick Xamarin. But there's reasons I picked Xamarin. Yeah, Xamarin means I can go Android, iOS. Can we not get the Windows Phone back? Who loved the Windows Phone? Yeah, we want it back. I was kind of hoping the Neo or Duo thing was going to be kind of, a Win phone, but sadly not. But it means that it's got native look and feel to the user because it is Android, iOS. It compiles to native code. Yeah, it's not some fangled dangle Microsoft stuff that sits on top. It compiles to native code. It's got full access to all the tools, so full access to the Bluetooth stack, awesome. It's written in C#, I know C#, I can do that. But the really, really important bit for me was it's got the accessibility built in. So Kayden's got an iPhone, I use Android. Kayden has his accessibility settings because he's only got these 2 digits, yeah, and his hook doesn't play with the phone. He has the buttons slightly bigger, so he can pause them a little bit bigger. You know, another child may have it slightly different. Another child may have, you know, eyes problems, that sort of thing. It's all built in, yeah? So I was like, I don't need to worry about that then. Android does it, or iOS does it, and they do it for me, and Xamarin sits on top and just uses that layer. So I went with Android, but sadly without the UWP instance. There's 2 flavors of Android with Xamarin. You've got traditional, which is your C# backend, and your front end, your UI layer is written in Swift and the likes to give you your UI layers for each of the platforms. Or you've got Xamarin Forms, which is where your UI layer is written in XAML, yeah, a Xamarin Forms version of XAML, and it means that you no longer need to worry about designing it for each of the different platforms, having to manage the iOS version, manage the Android version. So I went with Xamarin Forms because it's easier. It's a very simple app. There's not a lot to it. So I went with that. But also, just when I was starting putting the Xamarin app together, David Ortnow, who's a program manager for Xamarin team, launched and talks about the Xamarin shell, which means that you don't need to worry about the navigation stack. Those of you who've done Xamarin work before know that the navigation stack is a pain in the backside. You're writing the same boilerplate code all the time, and it's like, you know, copy and paste it across. But with Xamarin Forms, you don't need to worry about it. So I'm going to start off by looking at this. So this is the app delegate. So this is sitting inside my iOS project. Yeah. So you get your 3. I can do this. You get your shared projects, yeah, which is your .NET standards. You get your Android and your iOS projects inside as well. The only change I have made to the iOS projects is these 4 lines of code. And the only change that I wrote, because I obviously did file new Xamarin projects, the only 2 that I added was forms material and list review under India. Those 2 were already brought in for me. So it's 2 lines of code in the iOS project. That's it, I'm done. Leaving it alone, never touching it again. Yeah? In the main activity of the Android project, because I made the text bigger, it's not got it where I want it to be. I've added, again, the same couple of lines, forms material, and I did you have to do the dialogues in the Android as well. So 3 lines of code in the Android project, and I'm done. Leaving it alone. Don't open it again, don't touch it. That's it, it's done. And then in the bottom there, it says load application, and it says new app. Yeah, so that's where Xamarin Forms loads the application. So it then calls into your app class, and this is the app, as you can see there. I'm setting some device flags because I'm using some experimental things in there. I think carousel views now, not experimental, is it? It's done now, isn't it? I think it's baked. Yeah. Yeah, we've got a Xamarin MVP back there, so she'll know. But so I'm using some experimental things in there, and so set those flags because I want to use the new hotness. Create an instance of my Bluetooth service, which we'll go to in a minute, and then I'll start the app shell. That's it. That's my main project done. And then in your app shell, because it's in XAML, I set some styles at the top, and then I set a flyout header, which is the flyout is the page that comes out as you fly out, and I set a little header. At the moment, all I'm setting is putting a picture up there and making it fit with a bit of a background, a bit of padding. XAML, I mean, you know, you got these 3 flavors of XAML. You got your WPF, your UWP, and your Xamarin XAML. I mean, yeah, they use different kind of words and names in the XAML, but you look at it, you can kind of get the gist that a text box is a text box. You know, a label is a label, that sort of thing. A button is a button. It is slightly different though, so if you are coming from a different background, just bear that in mind. And then the pages. So I have a Bluetooth connection as a flight item. So it's one of the items in the flight menu. I set a title. I give it an icon. So I give it I use the font family. So I bring in a font pack for material font icons, and from that font pack, I'm just picking an icon. Thankfully, they had little handy ones, so they had a finger pointing up, which I was like, brilliant, I'll use that. Give it a color, and then I tell it where to go. So shell content is going to load this hand control view. And that's it. So you do the slide out, and that's all you get. And then I go down and add the extra ones. And behind this, the Xamarin shell picks up these data templates and does all the navigation stack for me. So if I go into that menu and go into that page, it gives me the bottom tabs, the top tabs, does all the navigation. It's absolutely amazing, the amount of work that's gone into it, and it's fantastic. It means that I no longer have to write pages of boilerplate for the navigation stack. It's just done for me, it's managed for me. So in my Bluetooth service, which I sort of talk about, is at the top, like I said, we have our services, and they're given GUIDs. So we've got our service GUID that says I want to talk to that service, and we've got a write GUID and a read GUID, because I said they were the characteristics, so we've got a read and a write characteristics within there. And all I do to connect is I'm using ACR Bluetooth, which is an open source library, to do the Bluetooth connection and control it for me. So it's a package I've bought in, a NuGet I've bought in, it allows me to do the Bluetooth. It is being put into Xamarin Essentials, which is a package that Microsoft built, well, James Bontemagno built, that does all the things like the Wi-Fi's and things like this in network. Is the phone on, turn the flashlight on and off. Now, they are bringing Bluetooth into it, but at the moment it's not baked. So I'm using an open source third-party provider, which works, it does the job. There's a few bits missing, but it does the job for me. So you create an adapter, you connect to the service, and it's all done in async, and then you connect to the read and write characteristics, again in async, to give you the memory locations. And then you have to invoke it on the main thread, obviously, to start updating the read characteristics. So as that read value changes, it will fire you back an event, which you then use to control and do things with. I've got lots of debugs and try catches in the minute at the moment, just because I'm trying to work out what's working, what's not. My plan is all these debug write lines will turn into calls out to App Center, which is where I get this built, and it'll be logging functions out to App Center. So then I can monitor the mobile app as it goes on. So that's it. That's pretty much it. That's the Bluetooth stack. If I go to Advisor, and this is an awesome tool. If I open the app, so first it's going to ask me to connect to the Bluetooth device. So let's quickly do that. I don't know what's going on. Oh, you know why. Flight mode off. You can see it's done an alert there. Bluetooth's changed from off, turn it on. There you go, it's turning on slowly. And there's handy at the top. There's all my alerts coming through now. And it's connected. So it's now connected to the hand. And you can see there's the fly up. So I said that I've got voicemail from the school. That's no good, is it? Let's turn that off, and let's turn mobile data off. There you go. We'll get back to that later. What's the little sod been up to now? So you can see here, that was my flyout with the image at the top, and there are data template pages, and it's all done for me. So I've got grip selection, grip ruler, grip builder, and then I've got some things for me, settings, Bluetooth connection, and UART control, which is a serial protocol, which I use to talk to the hand for development purposes. So if I go into UART, it should allow me to send the serial command that OpenBionics used to send to the board. And if we send that, fingers crossed, it should. No, hold on. It's got stage fright. There you go, it's connected now. You can see that it's flicking through. That's all the serial stuff that's been sent out, so it hasn't made the serial connection properly. It's something I'm working on, but hopefully, oh, you know why? It's because the muscle control's turned on. So that's using the sensors inside. So I just need to turn the muscle system off because you can either get it using sensors. So at the moment, when I send that command, I was saying close the grip, but the sensors were saying no, open the grip. So that's why it twitched. And so I switched across now. Oh, God. Anyway. No, I've unplugged the USB, that'll be why. Anyway, you can see it move. So that's the app, the mobile app that is doing it, and I've got the grip selection. And the idea here is I'm just using the collection view and flicking through them. You can see there, nice. Got the indicator view, that thing I talked about earlier. It's connected now. So and the idea here is that Kayden can flick through the grips that he's got. You can see a little heart on the top. He'll select the little heart and say I want that grip in my grip pack. And then the bottom tabs go to the grip order. And he's got a list of the grips that are in his grip pack at the moment that's loaded, and he can decide that I want that one at the top, I want that one to be second. I'll save that, it will save it to the board. Yeah, he can turn his mobile phone off, and now when he cycles through the grips, yeah, he can select which grip he wants in the order that he wants for him on that day. Yeah. Someone suggested yesterday, yourself, James, about you know, if we could put a bit of machine learning in there that says, oh, it's 9 o'clock on a Monday morning, he's going to school. He wants his school pack. Yeah, which will be just these 3 grips. You know, he's going to Scouts, he wants a knot tying pack. You know, I don't know, but, you know, whatever he wants as a person, he can build. Yeah, they've got the grip builder, which here allows him to set the animation step and then move the sliders. I've not finished this because there's some problems with the memory inside the board. I'm running out, which I'll come to in a sec. But he can move the sliders across and build his own grip. Had it, clear it, save it. Yeah, so he can build his own Xbox grip that he wants. Yeah, again, he doesn't need to go into that big 3D array to work it out and work out how to, I'm buzzing now, work out how to build a grip in a 3D array. He can build it manually, can move that slider and fingers will move, and it's like, right, that's where I want that bit to build. And then I haven't put a play button, but I'm going to stick a play button in there so I can click play and he'll play the grip sequence through and see where he's got to. But that allows him to build his own grip. Now, he may not be able to, he can do that because he's 15. A younger child may not be able to, but a parent can. You know, we can work that out, can't we? I don't think that's, you know, I've tried to be as simple as I can with the UI, and this is all open source. If you're looking at this, think to yourself, you know what, I'm better at UI than you are, Cliff. I know I'm not good at it. By all means, come along, talk to me afterwards, jump in and help with the project. I'd love to make this as simple as I possibly can, build the grips. So that means now that if we get one of these built somewhere else in the world, you don't need to have a specialist doctor or a software engineer that knows how to go in and edit Arduino code. So that's where we are at. So I'm going to put that down. If you can, don't you can hear it? Can it come out? Can you hear the motor? Just about going out. The pulse width modulation, which is used to control the motor inside, you can tune it out of the audible range, so you won't hear that. But the problem is, I tuned it out of the audible range. I got 2 little miniature schnauzers. It's in their audible range. They were barking and going bonkers. It took me weeks to work out. Every time I was playing with a hand, they come to me and started barking at me. I was like, what? Go away. And then I worked it out. I was like, ah. So, yeah, it's tuned back into my audible range so I don't upset the dogs. That's a problem that's still got to be solved. I've got to work out a way of tuning it out of their audible range, but then you end up with the PWM signal being too high that the controller board can't cope with it. So that's a problem that I've got to come back to. So, that's our Xamarin. I said that I build that in Visual Studio, yeah, using the Visual Studio tools. I then use GitHub, and as we all do, stick it out to GitHub and do my git merge and git commits, all that sort of stuff. Then App Center, free tool from Microsoft, picks up the fact that I've done a build on push, so it picks up that I've pushed something out. This is just an image because I didn't want to trust the Wi-Fi. It picks up that I've done a build, pulls it in, does a build, and then sends an email to Kayden and his mum that there's a new build that is for their team, because you can have different distribution teams. And then there's a distribution teams with me. So if I push the dev branch, it only comes to me. If I push to the master branch, it goes to everyone in the group. Yeah? And you can control that group, what they get, the messages that get sent to them, whether they get the git commit message as part of the email that says this is what's been changed. That's how I've got it set at the moment, so that makes a bit of sense to them. Means you've got to be careful what you write in your messages. But this is a free tool. Yeah? You get a limited number of builds. I think it's 60 minutes a month, I think it is. Build minutes, I think, actually, I've got the next slide. I put this in this morning, just to answer it myself. You get 240 build minutes per month and up to 30 minutes per build. So your build can be 30 minutes long. A Xamarin build is about 3 or 4 minutes long. And you get 240 build minutes, so Android and iOS, because I need both, obviously. But I can do this, which means I don't need to carry a Mac with me around the world to build for the iPhone. I can literally do a push to the dev branch, and then my iPhone gets 5 minutes later, it gets a message to say there's a new iOS build. Download it, and I haven't got to carry a Mac, which means I'm now a completely Windows device. There's a new tool from Microsoft, Hot Restart, which means I can plug my iOS device into my laptop and build locally to my iOS device without ever touching a Mac, which is phenomenal. It's really, really good. It's just I'm having some problems because I was a beta tester for it, and the beta bits are messing up the real live bits now, and I didn't want to play with it too much before a conference talk. So you can see there, the paid tier gives you unlimited build minutes, gives you testing and stuff like that. It's £40 a month, which isn't a massive amount, and it comes off your Azure bill because it's all linked to your Azure account. So if you've got free Azure credits, you're not going to pay for it anyway. So that's that. So back to our drawbacks. We solved the iOS sensor by switching to the full sensitive resistors. We solved the processor by switching to the Adafruit, and the store was closed anyway, so I'm glad I did that because they don't no longer sell them. And we solved the other elements by having our own grips and everything else stuck in a Xamarin app, which is building. We ended up with a build that looks like this. So we've got our 4 actuator motors. I've done these nice and big, so you can see the motors go, and they're basically a little piston goes in and out. And what that does is it pulls on a piece of string. I'll pass it around again. You can see inside the little bit of string, and what that string is a 100-pound braided fishing line. So again, that was something OpenBionics used, which was quite expensive. I switched to braided fishing line. It seems to work. It's about £6 for a massive reel of it that will last me forever. So that's in there. So it pulls on the string, and as the motor piston goes out, it pulls on the string and coils the thing around. Because the string's getting shorter, it coils it around. And then if you look in the back, you can see the springs. As you release the motor, the springs pop it back. It's as simple as that. It really is not difficult at all. You're still buzzing, aren't you? And then we got full sensitive resistors, and we got Bluetooth connection to our Xamarin app. Got to love my drawing, haven't you? This is why my UIs are so good. So, costs. You're thinking to yourself, well, Cliff, you said that the plastic was about £5. All right, you paid £800 for a printer. The new Prusa printer, the Mini, is £300, and it can print all of these parts. You can get 3D printers that are about 100. I think Shahid was talking about a printer he bought recently. I think it was about £150. He's got to put it together yet, take it out of the box. He'll get around to it one day, he says. But you can print all these parts on a relatively cheap printer. Yeah. The expensive bits are the motors, but at the moment, this is my spend. Yeah. So the Adafruit ball is £28. The motor controller is £18. The 2 step-up controllers are £4 and £11. There you go. Full sensitive resistors, they're £6.90 each, but I need 2 of them. The battery, the one that I've got there, is £20. The 4 motors, they're £84 each. So I'm spending, what, £437? Yeah. On top of that, you need springs, screws, and bits of cable and things like this, which add about another £70 to £80 at the moment. But I've been going through systematically. I've removed some of the springs that were inside. Because I don't think they're the ones that they've spec'd are needed. We can go to a cheaper brand. They don't need to be all singing, all dancing springs. They're just springs. So I'm again getting the price point down. I'm hoping that I can get this down to that number being less than £500. Yeah, plus £300 for a printer, which means less than £1,000. And they can print. And because you're buying the plastic in spools, a kilo spool, which will print around 2.5 to 3 hands. They can buy this, get these, and build the hands for a local child. One of the things we've been working really hard on is this fits Kayden really, really well, yeah, like a glove. And every time he grows a bit, we just print a new one, slightly bigger. But that fits Kayden. That took a lot of effort to build that and design that to fit Kayden. So Macaulay, again, my oldest son, is tinkering, playing, come up with this design, which uses a bit of Velcro. This is printed in PETG, so it's flexible. And all that happens is you just tighten the Velcro, and it tightens around the arm, around the forearm. Kayden's tried it. He's not keen on it because he says the back here, he prefers the support here. So literally we tried this a few days ago, and so Macaulay is now designing this that comes up to give support around the back of the elbow, and we'll try that on again. But I'm hoping that there will then fit any child. We'll just print a small, medium, and large version, and they can use the Velcro to tighten it up. Yeah. So again, we're iterating the design and trying to work out what works, not just for Kayden, for other children. So what's next? We've got a few minutes left. I'm a .NET developer. I've really invested a lot of time and effort into this now, and I'm really enjoying it. I've learnt loads, and I hate the Arduino programming language, it drives me bonkers, because something that would be really, really easy to do in .NET takes forever in Arduino. So I do that. Just a side note though, if you're doing Arduino development and you hate the Arduino IDE, you can use Visual Studio, VS Code, which will then use the Arduino IDE underneath. So you've still got the problems of the Arduino IDE, which is horrendous, but using VS Code, which is slightly better. Or you can go to full Visual Studio, and there's a tool which is free to download and use, an extension called VS Micro, and that will give you the full capability of doing everything in Visual Studio with all the loveliness of Visual Studio and the extra tools. And the advantage of that is you then get back your F9 breakpoints, and you can get a breakpoint in a microcontroller, because what he does is when you get to that breakpoint, he artificially inserts a wait loop that sits there and just sits there doing nothing until it receives a signal to say step on with an F11. So you can then hover over the local variables and you can get some of the data out, or what you do is you do a print statement next, and you step into that print statement and you can see the data coming out. So it means you get back some debugging, which you can't do in the Arduino IDE. So that's awesome. But I want to go full .NET, and I'd love to find someone who's got some skills in machine learning that will help me work out these sensors. So it auto-adjusts the sensor readings. So on a Monday morning, he's a bit tired, it'll adjust for him. So, not sure if you've heard of it, WildernessLabs, they've got an F7 micro, which is this wee board here. It's based on the feather system from Adafruit, so it's exactly the same pinout, so it will drop straight into the system. It's slightly longer. You can see the red box there is the bit that's a bit longer than the feather board. But this is full .NET, running on a mono runtime on a board here. And these are about $50 at the moment, but they're hoping to get the price point down when they do big batch builds. The advantage is, it's got lots of things. So it's got Bluetooth, it's got Wi-Fi, it's got analog input, it's got the full .NET stack. It's awesome. It's fantastic. Problem is, it's only just come out of Kickstarter. It's really new. And the problem it's got is the fact that the Bluetooth and Wi-Fi stack are still not published. So that's why I've not been able to use it, even though the talks about me using it, is the fact that they're waiting for beta 4, which comes out in March, which had the Bluetooth stack in there. The I2C, which I was using to control the remote control board, is a bit buggy. They're aware of the bugs. We've done feedback, and they're fixing those and say they'll be fixed for March when beta 4 comes out, along with some other bits that need to be fixed as well. So I'm hoping around March, April, I'll be able to go full .NET and put that. I'm going to move it up into the arm, which takes the weight out of the hand, because obviously more weight out here is not very nice, and it builds muscle. If I move it up here, it means it's going to be lighter and better for him. So, why do I mention being a pilot? I've talked about it a few times through the talk, yeah? I would love, once we've got this sold for Kayden, is to put a box together with a 3D printer in it, with a couple of spools of plastic, some nuts, bolts, screws, that sort of thing, and take it somewhere around the world. I'm looking for that first place, not sure where it is yet, but take it somewhere in the world, teach the local people that are there, the doctors, the nurses in the prosthetic hospital, of how to build this and make this themselves, and then let them, I can go backwards and forwards as I do, and let them build these for the local children somewhere else in the world. We've got the NHS, which is fantastic, and it's just a hook. So if there's someone in the UK that wants one of these as well, reach out to me, contact me, and I'll help you build it and go along with it. I'm really passionate about this project. It means a lot to me. I want to say thank you to Kayden and his family. Without this, I wouldn't have started this journey. Without Kayden being as supportive and being the grumpy teenager that he is sometimes, and giving me the feedback, which has been brutally honest at times. It's like, oh man. But without his brutal feedback, I wouldn't have got this far. Yeah. If I'm out of time for questions, but if you want to jump in, here's the mobile app. I forgot to put the link on, but the software that's on the board is also on my GitHub as well. It's also open source, and all the 3D prints are forked as well, and they've been heavily modified in the back of the hand and parts of this to fit our boards, and all the arms, the socket, everything is open source on GitHub. I'm never going to close source it. If anyone wants to print it, get in contact, please jump in. And if you know anything about machine learning, you know someone that does know something about machine learning, I'm very interested to find out. That's my arm, that's my talk. I'm out of time. Thank you very much.